Question 19. Sorry, it's a little messy here. The car starts from rest and reach 48 kilometers per hour in 1 minute. Now this is quite a confusing units given. Some of them in kilometers per hour, some of them in minutes. So before I go on, I want you to take a look at what is the unit that the question is asking for. And the question wants you to give the unit. Actually, this is quite a strange unit to use. But anyway, the question say, give your answer to kilometers per hours square, which means that when you write this formula, the speed must be in kilometers per hour, the time must be in hours. So this one is in kilometers per hour. So how do you change 1 minute to hours? You divide by 60. So this is in hours. So your answer is 2880. Okay. So just take note that you need to make the necessary conversion of units. For B, the car travels for 15 minutes before stopping. So what is the distance traveled by the car? So again, distance is speed times time. The question wants me to, the answer is needed to be in kilometers. So which means the speed must be kilometers per hour. The time must be in hours. So this one is in kilometers per hour. This one is in hours, right? And so you will, again, I want to refer you back to this same diagram here. So if I want the distance to be in kilometers, then I must make sure that the speed is in kilometers per hour and the time must be in hours. So I must use this combination. So I do all the necessary conversion and I'll get 104 as the answer. Question 21. The acceleration, final minus initial. I think this one should be quite alright. 1.5 meters per second square. Question 22, you're familiar. The force can make an object turn. The force can change the shape and direction and speed, but a force cannot change the mass, of an object. Question 23. So again, this is 40, this is 50. And there are 10 divisions. I always count the number of divisions. I cannot assume the next one must be 41. But so there are 10 divisions, so that will be 44. What is the length of xy? Again, this is 0, this is 50. This is 50, this is 100. And when I look at it, the markings, there are 5 main markings. So for 50 centimeters, there are 5 markings. That means every marking is for 10. So 50, 60, 70, 80, and so on. And y happens to be between 70 and 80. So that's 75. This is 0. So 75 minus 0. Okay, so 75 is the answer. And then finally, this is the last one. Oh no, not yet. Okay. So these are the two timing, and this is where you hear, this is where you see the lightning, and this is where you hear the thunder. So what is the interval? So this is no minutes, so 7 seconds, 7.47. This is 5.31. So you subtract, the interval is 2.16. Okay, last question. This is a distance time graph. As you can see, the shape varies a lot. So which part is the car stationary? Stationary, at rest, not moving, they are all represented by horizontal portions. So there are two horizontal portions, C and E. Which part shows the object slowing down? Now remember, constant speed is like that. So this is still moving, but the speed is constant. If the speed is increasing, you will see the curve becoming steeper. So in this case, the speed increases, right? So it becomes steeper and steeper. But sometimes an object may slow down, and this is the shape. So this is where the speed decreases, or what we call deceleration. It should show the gradient, it should show the graph, becoming less and less steep. So in this case, B will show that it is decelerating because the thing is becoming less and less steep.